And the other one is double pipe heat exchanger. They are simplest of all type of heat exchanger. They are made of two pieces of pipe, one inside the other, and one fluid flows through the inner pipe, while the second fluid flows through the annulus between the pipes. So flow inside double pipe exchanger can be current or counter current. We've seen this concept before. Like its advantages are inexpensive and easy to design for high pressure service. This double pipe heat exchangers. As you can see, this one we don't have two pipes, this one and this one. So we don't have the hot fluid in, and we don't have cold fluid in and fluid out. So this really looks like the counter current flow. And also we have co-current flow, in which we have the hot fluid in and hot fluid out, and cold fluid in and cold fluid out. Like they are moving in the same direction. Co-current flow. We call them this parallel in the same direction, but here in the opposite side. So we call them counter current flow. And their disadvantage is like they are difficult to clean and they are suitable only for small sizes. These kind of heat exchangers. And the other one is multi-pass heater. The other one is multi-pass heater. So this one is in multi-pass heater. In multi-pass heater, the volume of fluid can be increased. This causes increase in heat transfer coefficient. So we can increase the volume of the fluid. We can increase the volume of the fluid, and if we manage to increase the volume of the fluid, what we are doing is we are increasing the heat transfer coefficient. So liquid to be heated is passes through the tubes several times before leaving the equipment. Before it leaves the equipment, the liquid, it should have to move through the tubes several times. This facilitates the effective transfer. Therefore, multi-pass tubular heaters are superior to a single pass shell and tube heater. Its construction it consists of number of parallel tubes. The bundle of tubes is wrapped in a cylindrical casing, and also the chambers are provided at each end of casing. Since the heater is multi-phase, the same liquid has to flow through several tubes back and forth, like it's kind of rocking chair mechanism. They should move back and forth through the several tubes. This one is like multi-phase heater. The working is like the feed is entered in the compartment A of one of the head. This enters the fluid, and then it's passed through the tubes into compartment B of the other head. Should have to pass through the tubes into compartment until B. Then the fluid back through the other sets of tubes to compartment. And after it goes to B, it should have to return into C, and finally leaves through the compartment of I. The fluid is diverted by using baffles. Since the heater is multi-phase, so same liquid flows through the several back and forth. As I said like before, it's kind of rocking chair mechanism. They move back and forth before they leave the equipment. It's advantage like they are superior than single pass shell and tube heater. They are disadvantage like the first one is fabrication of the heater is more complicated. Like there is kind of complicated fabrication if we want to develop the heaters. And the other thing is the pressure drop through apparatus increased because of enhanced volume of fluid flow. If we are increasing, even though we are increasing because of increment of speed, we are increasing the heat coefficient, but also there is a pressure drop we need to consider.